Hello, welcome to Chapter 14, the autonomic nervous system. So this is the fourth video in our series on the autonomic nervous system. Let's make sure our pen works. So this video we're going to talk about interactions between the parasympathetic and sympathetic nervous system. So we've seen this cartoon in the previous videos. On the left side is parasympathetic innervation, the right side is sympathetic innervation, and you can see that the parasympathetic and sympathetic divisions of the autonomic nervous system innervate the same structures. So for example, the parasympathetic nervous system innervates the eyes, so does the sympathetic nervous system. When parasympathetic innervation is turned on, well, they're both kind of turned on at the same time, but when parasympathetic innervation is on, the pupil of the eye will constrict. When sympathetic activation is on, the pupil of the eye will dilate. And the adrenal gland is innervated by the sympathetic nervous system, but not the parasympathetic nervous system. So this first bullet, it says most visceral organs have dual innervation, and these are all visceral organs except the skin. Because the sympathetic and parasympathetic are for the most part antagonistic towards each other, that means if one does one thing, the other division does the opposite thing. They call that dynamic antagonism. But because Mother Nature designed this dynamic antagonism between parasympathetic and sympathetic nervous system, this allows for really precise control of visceral activity. So, for example, your heart, lungs, and stomach. The sympathetic division, remember, that's fight or flight. So the way you can think about what's going to happen if the sympathetic division is activated, think about everything that you need to increase or that you need to do if you're in a fight situation. So, for example, you want to increase your heart rate, you want to increase your breathing rate or your respiratory rate, and you can, when you're in a fighting situation, you don't have to worry about digestion or elimination of your waste products, so you inhibit those. Parasympathetic is rest and digest, so you're going to decrease your heart and respiratory rates, but you're going to increase your smooth muscle activity in your GI tract, so you can digest things and eliminate waste products like urine and feces. So we talked about, I think we showed this slide in the last video, but sympathetic tone allows you to maintain your blood pressure. So in this cartoon, here's an artery that's cut. The walls of the artery are made of smooth muscle cells. This is the sympathetic nerve fiber or axon coming down, innervating the blood vessel. These hash marks represent the frequency of action potentials. So with sympathetic tone, you have this high frequency of action potentials telling these smooth muscle cells to contract. That allows for constriction or vasoconstriction of the blood vessel. Come down here to the second, letter B, vasodilation. The action potential frequency is lower. That means there's less stimulation of the vascular smooth muscle cells. They're less highly contracted, so you get vasodilation. But this sympathetic tone, which is shown in A, keeps the blood vessels in a continual state of this partial vasoconstriction. Then when you need to vasodilate, sympathetic action potentials will just decrease in frequency and the blood vessel will vasodilate. If you use an alpha blocker drug that can interfere with the vasomotor fibers, that's these guys, fibers or axons, and you can use them to treat hypertension. So if you block the alpha adrenergic receptors on the smooth muscle cells in the wall of the blood vessel, you can allow for vasodilation, thus treating high blood pressure. This cartoon shows parasympathetic tone. So the previous one was sympathetic tone. This is parasympathetic tone. So here's parasympathetic nerves, and it shows them innervating the heart. And then the sympathetic nerves are also innervate the heart. But both parasympathetic and sympathetic divisions innervate the pacemaker. That sets the rate of your heartbeat. They both innervate the AV node, so you'll learn all about this in 202, but that signal initiated in the SA node has to travel through the AV node before it gets to the ventricles and the myocardium that allow for the strength of a contraction. Sympathetic nervous system innervates the cardiac muscle that allows for contraction strength. Parasympathetic does not. So parasympathetic normally dominates the heart and also the smooth muscle cells in the digestive tract and the urinary tract. So for example, the bladder. Parasympathetic tone keeps the heart rate slow. So if you cut the parasympathetic nerve to the SA node here, so you cut it, the heart rate will increase. So parasympathetic tone keeps the heart in a healthy 70 kilogram 20-year-old male between 70 and 80 beats per minute. Parasympathetic tone also dictates the normal activity of the digestive and urinary tracts. So parasympathetic tone dictates the smooth muscle cells in your digestive tract and your urinary tract. During times of stress, sympathetic nervous system can override parasympathetic tone. So for example, in a fight or flight situation, whereas the parasympathetic nerve is keeping the SA node at a slower rate, sympathetic can override and increase your heart rate. If you are a drug and you block the parasympathetic response, then you're going to increase heart rate. Because remember, parasympathetic tone is keeping the heart rate low. If you block that parasympathetic event with a drug, then your heart rate's going to go up. Cooperative effects in the autonomic nervous system are best seen in control of the external genitalia. So external genitalia in the male, you see the penis, external genitalia in the female is the clitoris here. Cooperative effects. So this is where instead of the parasympathetic and the sympathetic nerve divisions being antagonistic to each other, they cooperate to allow humans and probably other primates to achieve an orgasm. So parasympathetic fibers will cause vasodilation. That allows for the penis to get erect and also for the clitoris to get erect. So that's parasympathetic nervous system. And then sympathetic fibers cause ejaculation in males, so ejaculation of the sperm in males, and also smooth muscle contraction in the females to allow the sperm to move from the vagina into the uterus and then the fallopian tubes, looking for an egg, of course. So cooperative effects continued. This is enticement, excitement, and orgasm. So this is where parasympathetic and sympathetic cooperate to achieve an orgasm. So in the enticement stage, the sympathetic nervous system is activated, and you can become sexually attracted to someone. That's a sympathetic response. The excitement phase is the parasympathetic nervous system, where you get, it says male erection, but it's also female erection of the clitoris. And then in the excitement stage, under parasympathetic nervous system, females can lubricate, so the vagina becomes lubricated, ready for copulation. And then finally, cooperation of the autonomic nervous system yields an orgasm, and that's dominated by the sympathetic nervous system, where you get male ejaculation of the sperm and female orgasm. So that's smooth muscle cells contracting to aid the sperm traveling towards its final destination, which would be the fallopian tube. So this just says the unique roles of the sympathetic division. We've talked about this before. In the sympathetic division, you have the adrenal gland innervated by the sympathetic nervous system, but not the parasympathetic division. So it says here the adrenal medulla, so we just talked about that, the sweat glands, the erector pili in the skin. You can't really see it in this cartoon, but there's an erector pili muscle attached to the hair, and then when that erector pili contracts, the hair stands on end, making you look, well, if you were really hairy, it would make you look bigger. Let's see, the kidneys and most blood vessels receive only sympathetic fibers. So the adrenal medulla only gets sympathetic axons or fibers. The sweat glands, erector pili, kidneys, and most of your blood vessels will only be innervated by the sympathetic nervous system. So the sympathetic nervous division controls perspiration. So that's your regulatory response to heat. Release of renin from the kidneys, and you'll talk all about that. So here's a kidney. Talk all about how the sympathetic nervous system allows for release of renin from the kidney, and renin will go on to raise your blood pressure. Metabolic effects of the sympathetic nervous system, you increase the metabolic rates of your cells. You'll raise blood glucose level, which is what you want if you're trying to fight someone. Your skeletal muscles need glucose and oxygen to operate, so blood glucose will be raised. And then also if you're in a fight or flight situation, sympathetic nervous system will mobilize fat, so you can use that as fuel. Okay. Localized versus diffuse effects of the autonomic nervous system. The parasympathetic division, its effects, so when you turn on the parasympathetic nervous system, the effects are short-lived and they're localized because parasympathetic nervous system releases its neurotransmitter only onto the target organ and not in the bloodstream like the sympathetic nervous system does. So the sympathetic nervous system, when it innervates the adrenal gland is stimulated and it releases norepinephrine and epinephrine into your blood, and then those two neurotransmitters can travel all over your body, and wherever they find an adrenergic receptor, they can bind and have an effect on that tissue. So they say the sympathetic division, its effects last a long time, and the effects are body-wide. That's because its neurotransmitter is put into the blood. Norepinephrine is inactivated more slowly than acetylcholine, so norepinephrine stays around longer. Remember, acetylcholine from the parasympathetic nervous system, there's acetylcholine esterase that can break down acetylcholine, breakdown of norepinephrine, and epinephrine happens more slowly. And then we just talked about this, norepinephrine and epinephrine are released into the blood from the adrenal gland, specifically the adrenal medulla of the adrenal gland. And it stays there in the blood until the liver actually breaks down epinephrine and norepinephrine. Hypothalamus is really important in control of autonomic nervous system functioning. So let's take a look. It says, here's the hypothalamus, overall integration of the autonomic nervous system. So the hypothalamus is the boss of the autonomic nervous system. It communicates with the brain stem. So that's the midbrain, pons, and medulla. Also the reticular formation. The hypothalamus will eventually lead the autonomic nervous system to regulate pupil size, respiration, heart rate, heart contraction, blood pressure, swallowing, all these things. But you can see that, so even though the hypothalamus is the boss of the autonomic nervous system, the hypothalamus gets information from the limbic system. Limbic system is your emotional center. Limbic system also is a two-way street of communication with the cerebral cortex, your frontal lobe. But the hypothalamus is the main integrative center of the autonomic nervous system. The cerebral cortex can modify the autonomic nervous system, working through the limbic structures and the hypothalamus. Vital centers live in your brainstem. Remember, that's the midbrain, pons, and medulla. Vital centers include your respiratory center, your cardiac center, your swallowing center, etc. So the brainstem exerts direct effects over the autonomic nervous system, but the brainstem is affected by the hypothalamus. The hypothalamus is affected by the limbic system. The limbic system can be affected by the cerebral cortex. So it's really all this two-way traffic to control the autonomic nervous system. Hypothalamus will control via the autonomic nervous system, heart activity, blood pressure, body temperature, your water balance, endocrine organs, biological drives, how you react to the fight or flight system, the sympathetic system. And then it says here, this check mark, it says emotions influence autonomic nervous system reactions through integration in the hypothalamus. So we talked about that on the last slide. You can see there's two-way traffic. So there's input from the limbic system into the hypothalamus, and there's input from the hypothalamus to the limbic system. So it's two-way traffic.